So yeah, hello. My name is Martin Alig. I'm currently working on my master thesis here at ETH. And as you can see from the title, it's about log analysis using technologies like HBase and Solr. And yeah, I'll show you what I do for my thesis. So the overview, I will give you an introduction, what is the problem, then present you our ideas, what kind of solution we have, then I will give you an introduction about HBase and also short about Solr, and then some details and a couple or a few results at the end. So the thesis is in collaboration with Amadeus. Amadeus is engineers IT systems for the travel industry. So all the systems for booking, reservations, for checking at the airport, and for all the baggage, all the systems that they use at airports, for example. And so to give you numbers, in 2010 they had about 850 million transactions, and so you can see they have quite big computer systems. And those systems generate many logs, and currently they generate about around 100 to 1 million messages per second. And message has an average size of 1 kilobyte, and it can be almost anything. So it can be XML, it can be HTML, it can be some other formats like ETH, which is used in this industry, or it can be just a hex dump or anything. And so it's really unstructured, but and we have only a couple of fixed attributes that we know from each of these messages. For example, a timestamp, or where the message is coming from, or different IDs that are attached to the log message. So right now what they do is they just write the messages into plain text files. After some time they split the text files and compress it, and they put it on a storage area network. And so now if they want to go through the logs because they have an error, or if they want to find out anything, what went wrong in some kind of system, some part of the system, they basically have to go through text files and do some distributed grep or something like that. And it's the log files are very important for them. For example, when clients come and complain about something, or they also would like to do more statistics, for example, or they would like to monitor some systems based on the logs, so that they could react faster when something goes wrong. And yeah, right now it's not possible, as they generate multiple terabytes per day, and so they are very limited what they can do right now. So our idea, and what I'm doing for the thesis is we try to use HBase to store the data and to access the data, and to use MapReduce to do queries on the data, and as another part to use Solr to index the log messages. Okay, so first about HBase. It's open source. It's a non-relational distributed database. It's modeled after Google's BigTable, and yeah, it uses HDFS, the Hadoop distributed file system, to store the data. And simply said, it's a key value. So a couple terms for HBase. HBase stores the data in regions, a region is basically just a certain range of rows where data is stored, and the regions are then automatically split or merged and distributed over the servers. Then the region server, it's a slave of the system. It keeps the regions and inserts data and reads data. And then there's the master. The HMaster, it's responsible for coordination. It makes sure that the regions are at the right place, and it detects failures, and it has some admin functions. So the architecture, simple or simplified. So we have the region servers, multiple, and they use HDFS to store the data. Then we have the master. We can have multiple masters to make it fail-safe. Then HBase uses Apache Zookeeper to elect a master in the system. And then we have the client, and the client first contacts, if he wants to read or write data, it contacts first Zookeeper, and Zookeeper tells them the client where he has to go to insert data or to read data. Okay, so to access the data we can use Java. HBase is implemented in Java, so of course, but you can also have a REST interface or Avro or Thrift as serialization technique, or of course we can also use MapReduce to read data or also to write data. Then, so as it's a key value store, as long as you know the key, you have really good access times. You can basically instantly access your data. But if you don't know the key, or you, for example, want to query on an attribute, you need some kind of secondary indexes. HBase does not support secondary indexes, so you have to do it by yourself. And what you can do is you have one side the data table where you keep your data, and then you also have an index table where you keep your index. And then what you can do, for example, is that you each time you insert a data, you also update the index table, and then you have a secondary index. And of course you can have it multiple times. Yeah. One way is to have it on the client side, to manage it from there, or you could use, for example, also MapReduce to add an index to your data periodically, or coprocessors that create the index. I will show what coprocessors are now. A coprocessor is a feature of HBase. It's basically a code that you can run on your nodes, or code that you can run on your nodes where you also have your data. For example, you could say that each time I insert a value, I also want to do some computations on that value. For example, by executing it after each insert, or before each insert, or when you get the value. And you could use it to create an index, or to, create some statistics on your data, increment some counters, something like that. Then there's also something called endpoint. It's also a way to execute code on your nodes on client request. So what you can do is basically you have some kind of distributed computations where your data is. Okay, so that was it for HBase. Now Solr. This is the only slide about Solr. It's basically Apache Lucene plus many more features. Apache Lucene is a text search engine library, and Solr basically wraps that in the core and adds features like distributed index, distributed search, or also nice web interface. Yeah, stuff like that. So we have chosen Solr because it offers those distributed capabilities. So, more details about what we are trying to do is, we have a client that inserts the logs into HBase. It also creates the secondary indexes on the attributes that we have from the log traces. And then on HBase we have a code processor that after each insert of log data, it also forwards the data or the log message to Solr, and Solr then does a full index over all the data, over all the log messages. So yeah, so then we can use Solr to search for anything in the log messages, and Solr will give us back the key where the data is in HBase. But yeah, HBase itself can also access the data from there by MapReduce or just making. So the setup or the configuration would look like this, so that we have so each square is a node in the cluster, and on the slave nodes you would have a data node which comes from HDFS, then we have the region server from HBase, and we would also have a Solr instance running in that machine, so that when the region server forwards the messages directly in the local machine. And then the master client. So the question is, is Solr fast enough to index the messages? And it's probably not. But yeah, and the other question is Solr, is it really practical to have a full text index over the log messages? I don't know. Yeah, when we have these formats like XML, it's really useful. So, results. Not so many yet, I'm still working on it. And I just received the real data from Amadeus 2 weeks ago. So before I had to do some experiments with random data, generated data. So I tried out what performance this HBase has, and is it even possible to be in the numbers that I mentioned at the beginning. And so, just to give you some results, so I have used a 5-node cluster, where one node is the master and the others are slaves. I inserted just random data, 1 kilobyte each record, and once I did it with secondary indexes and once without. And the secondary indexes are just 5 additional indexes on 5 attributes. So, no secondary indexes, I had around 30,000 inserts per second. And with secondary indexes, not so many, no. And
can I ask some questions?
Yeah,
sure. Should I talk or should I wait?
I'm almost done, so I think
okay. That's great. Do you have some ideas why the performance for the secondary index is so bad? I guess it's not Solr.
Okay, oh sorry, I forgot. This is without Solr. This is only HBase.
Okay, and where do you process the secondary index?
This is the client also inserts the secondary indexes.
Okay.
So this is basically for one log message, it does 6 inserts.
Okay, so this is not the issue with HBase.
No, this is
okay.
It's expected that it be inserted.
Okay, and do you have some experience with the throughput of the code processors?
So constructing the secondary indexes with code processors?
Yeah.
No. Actually, I'm thinking about to look at this.
Okay.
So it might be better.
From our perspective here, this is pretty much the same architecture as we use, and we have some experience with code processors.
Yeah.
Huge amount of inserts, and by the way, 1 million records per second to HBase is not that issue.
Okay.
It's up to performance. So
yeah.
you have to perform the cluster to run such load, but HBase can handle it.
Yes.
until you get in touch with co-processors. Then things get difficult.
Okay.
Okay, but anyway, we have a lot of experience, so we can talk about
Sure. Yeah.
afterwards.
Yeah.
Give you some ideas where your pitfall might be.
Yes. Yes. Okay. So using Solr, the performance is not so good anymore. So I just did short tests because I just received the data last 2 weeks ago. And so right now Solr is able to index 1,000 log messages per second. So far away from what it should be. But it's, yeah, I hope to improve it. So, yeah.
Interesting architecture. How does it scale with the number of nodes? Do we have any idea how would it scale? No? So if you double the number of nodes.
So I think HBase itself will scale, probably, because there are really large deployments of HBase. You can add Facebook or Yahoo. If Solr scales, I cannot say, because there are not so many large Solr deployments, or I haven't read about any. So. Hard to say, and I'm a bit limited here at ETH. We don't have too many hardware. And the one we have is not so good. Yeah.
About Solr can also be much faster. Question is if you use binary updater, how do you?
Yes, so I have to say about the Solr part, I basically just started there. I did not, Solr itself is quite a big system, and I still have to get in there. So if you have any tips for me, yes. Yeah, sure.
Some improvement.
Yeah.
But basically you just use Solr to index the log messages, nothing else.
Sorry?
You don't do anything else with it?
No. So the point there is that the messages are so different, and they have, it can be anything. It's quite hard to kind of decode messages and try to bring some structure into the messages. Yes?
Did you test it with multiple shards yet, or was this just this one instance test?
I know that was this round. I think I did it with 4 shards.
Okay, and how are they distributed? Who says what message will get indexed where on what shard?
Actually, the plan is to index it on the local, so on the same node.
Yeah, the regions are.
Yes, exactly.
And then you make a distributed search
Yes.
over all the Solr emails.
Yes.
Okay.
So that's the plan.
Do you monitor the projects that are going on where the idea is to put search index in HBase?
Yes, I think. Yeah, I looked at that.
HBase.
Yes, but I think they're not so active anymore.
Yeah.
Or some of them. Not sure.
You need some master thesis to update.
Yeah, there are many. Yeah.
There's one issue with your architecture, and this is you have to operate 2 deployments. So you have always HBase
Yes.
and you have Solr.
Yes.
Different tools, different release cycle, different ideas
Sure.
behind it, and so on. And if it would be possible to put in the secondary search index on HBase, it would be great.
So
there are a few
the
projects.
Solr index.
Yeah, right. To
Inside
replace Solr search capabilities and put it on HBase.
Yeah.
And there are some projects around there, but they are, as you told,
Yeah.
not very active.
Yeah.
But the question is, how does it Google, for instance? They don't have a search index besides a big table, so there must be a solution around there.
Yeah, sure.